Hi, welcome to our math. Today I'm doing a series of videos on functions. In this video, I'm trying to figure out where two functions intersect. So I think it's easier to understand what's going on if you think about what the graphs of these functions look like. So for my first example, I have a cubic, which could look something like this, and a parabola, which could look something like this. So it could intersect at two places. It could intersect at three places, depending on how I drew it. There's going to be at least one intersection. I mean, if I had the cubic like this and the parabola like this, there would just be one intersection place. So there's several different ways it could intersect. The second one I have is two parabolas. And if I had one parabola that looked like this and the other parabola that looked like this, it could be two, it could be zero very easily if you had one parabola that looked like this and the other parabola that looked like this. So there's zero, it could be one again, kind of like this first example. So we have lots of different ways that these questions could turn out. And so what we're trying to do is we're just trying to figure out the x values. We're not sticking it back in to figure out the y values yet. We're not looking for the full ordered pairs. We're just looking for the input values that would lead to the y values, to the output values. Right now we're just looking for the input values. So to figure this out, let's come back down to give ourselves some room to work. What we're going to do is we're going to say x cubed minus 9x plus 51 equals 5x squared plus 6. This 3 right there means up to 3 answers. If we come back and look at this case where there is only one, that means that there was two imaginary answers and one real answer. So answers for these come in pairs of 2 real at a time. So it's either going to be 1 or 3 as the real. So I guess this was just a really bad drawing I did there. That should have been caught with 3, 1 or 3. All right, so I'm going to move. If I had only a singular x, I didn't have any exponents at all, I would move all my x terms to one side and all my non-x terms, my constants, to the other side, divide and solve. But as soon as I start getting exponents and variable term, more than one variable term, then I have to move all terms to one side and factor. That's just the way it goes. So I'm going to start by subtracting the 5x squared. X cubed minus 5x squared minus 9x plus 51 equals 6. Subtract the 6 over. X cubed minus 5x squared minus 9x plus 45 equals 0. Okay. We have 4 terms. Anytime there is an even number of terms, factor by grouping. So I'm going to group these 2 and I'm going to group these 2. I'm pulling an x squared out of the first 2 terms and a negative 9 out of the second. I always pull the sign down. X squared times x minus 5 minus 9. X, this is a positive divided by a negative, is going to be a negative. 45 divided by 9 is 5. I have right now 2 terms. This is one term, this is one term. Parentheses force a term. So when you look at that, you should see 2 terms. They each have a common x minus 5. What's in the parentheses is the same. If I pull out that x minus 5, the first term I'm left with x squared. The second term I'm left with minus 9. From here, I have a couple of ways I can solve this. One method for solving this is I could just go for it. I could come in and say x minus 5 equals 0, x squared minus 9 equals 0, remembering that's two answers. So x is equal to 5 or x squared is equal to 9. I have to square root this with a plus or minus. So x is equal to 5, negative 3 or positive 3. That's perfectly acceptable. The other way I could have done this is I could have factored this a little bit more and said x minus 5, this is a difference of two squares, x plus 3, x minus 3, which would then have led to the same answer. So you could just, because this is one variable, isolate, solve, just like I said before. If there's only one variable, you can isolate and solve. You just have to remember that if you have to solve an x squared, there's two answers, positive or negative. So if you think you're going to forget that, do the difference of two squares to make sure you get all three of your answers. I will tell you, as a teacher who's been teaching math for years, remembering that x squared minus 9 is x plus 3, x minus 3 is maybe one of those huge points that I take off of papers all the time. This is a really common mistake. Students stop at this x squared minus 9 all the time in a problem like this. They don't go all the way to here. So getting used to doing this just so that it is part of your muscle memory is not a bad idea, because it is a very simple factor, difference of two squareds, and the simple things are the things that we mind dump the quickest, and it's a silly point to lose. All right, so let's go on to our next problem, setting them equal to each other. We want to set x squared minus 9 equal to 5x squared plus 12x. Once again, we see an x squared, we see an x. That means we want to move everything to one side and factor. So I'm going to subtract that 5x squared from both sides. Negative 4x squared minus 9 equals 12x. Subtract a 12x from both sides. Minus 4x squared minus 12x minus 9 equals 0. Whereas I can't take a constant number out of all of these, I am going to divide both sides by a negative 1 to get 4x squared plus 12x plus 9 equaling 0. Okay, I will see something like this with the 4 and the 12, and students love 4s and 12s, and they will try to take a 4 out, and they'll say 4x times x plus 3, end parenthesis, plus 9. They don't know where to go, and then they'll stop, and that's how they'll turn in a quiz or a test. Trinomials, practice them. Again, muscle memory. You want math to be muscle memory. You want it to be where you see a problem, you do a problem. When you have a not equal to 1, you multiply. 4 times 9 is 36. Everything is positive. 1 times 36, that adds up to 37. 2 times 18, that adds up to 20. 3 times 12, that adds up to 15. 4 times 9, that adds up to 13. And 6 times 6, that adds up to 12. So what I just did is I found a replacement for my middle term. I want to turn this into a 4-term polynomial so I can factor by grouping like I did on the last problem. Grouping is one of the simpler versus doing all of this stuff. So I'm going to turn this into 4x squared plus 6x plus 6x plus 9. So I've just turned this into a 4-term polynomial instead of a 3-term polynomial. My trinomial turned into a quadrinomial. So just like I did on the last problem, factor by grouping. I'm going to take a 2x out of the first 2 terms and a 3 out of the second 2 terms. 2x plus 3 plus 3, 2x plus 3. What's in the parentheses are the same, so I write what's in the parentheses. Then I write what's out of the parentheses. Now, you might be looking at this and saying, hey, they're the same. Can I just write it as 2x plus 3 squared? To which I'll say, sure, I don't care. That is up to you. 2x plus 3 equals 0 when 2x is equal to a -3 or x is equal to a -3 half. So whereas the last one had 3 solutions, this one has 1. So this is a situation where the 2 touch at 1 point, which is not that uncommon. All right, I hope you enjoyed this video. Please subscribe to my YouTube channel, and I'll see you on the next video.